Hello students, we are going to start chapter 11 pressure. In this chapter you are going to learn about the pressure, types of pressure, liquid that is liquid pressure and gaseous pressure and its application. First we are going to define what is pressure. The force acting per unit area of a surface of an object is called pressure. That is the force acting on an unit area. How much force is acting on a unit area is called as pressure. The pressure of a surface depends upon the magnitude of the force acting perpendicular to the surface and the area of surface. The pressure always depends upon the force which is acting perpendicular to the surface and area of the surface. So formula of pressure is equals to force by area, that is force acting per unit area. So pressure is equals to force by area. Force is measured in Newton, area is measured in meter square. So SI unit of pressure is Newton per meter square, which is also known as Pascal. It is written as PA. 1 Pascal is equals to 1 Newton per meter square. So what is 1 Pascal? 1 Pascal is 1 Newton per meter square. Now variation of pressure with area. The pressure exerted by certain force acting on a surface depends upon the area of surface. The pressure always depends upon the force of the surface and also on the area of surface. Now if the force acting on the large area, then the pressure will be less. If force is acting on the large area, then the pressure will be less. Force acting on the smaller area, the pressure will be more. Smaller the surface area, the greater is the pressure exerted, and larger the surface area, the lesser is the pressure exerted. For example, take a tray. Fill the tray with the wet mud. Take 2 bricks of same size and same weight. Keep one brick A in the wet tray horizontally and the brick B vertically. Don't try to press it. Now take out the brick and see the depth. We can see smaller the surface area, the pressure will be more. Means the area which is the brick which has covered the small area, the brick will go deep. Larger the surface area, the lesser will be the pressure exerted. If the surface area of the brick was large, so it has not gone such a deep in a wet mud. In this way, the variation of pressure takes place with area. So smaller the area, the greater is the pressure. Larger the surface area, the lesser is the pressure. Now variation of pressure with force. Pressure is defined as force per unit area. As long as the surface area remains unchanged, an increase in the force leads to increase in the pressure. So if the area is unchanged, then increase in the force. If you have increased the force, then pressure will also be increased. Suppose if we take an example that a force is applied, a force of 600 Newton is applied on an area of 2 meters square. Okay, 600 Newton of force is applied on area of 2 meters square. Then the pressure we get 300 Pascal. Now force area has remained same, 2 meters square. Now the force has been changed to 800. Then pressure will become 400 Pascal. So keep the area constant, increase the force, then pressure will also increase. This is the variation of pressure. Surface area if remains unchanged, an increase in the force leads to the increase in the pressure. If you increase the force, keep the area constant, increase the force, the pressure will also increase. Next, fluid pressures. First the question arises, what are fluid? Then what are fluid pressures? Liquid and gases are collectively called fluids. Why they are called as fluids? Because liquid and gases can flow, so they are called as fluids. Fluids exert the pressure on the object immersed in them and on the walls of the container holding them. Fluid exert the pressure on the object immersed in them and on the walls of the container, uh, holding them. This pressure exerted by the fluid is called as fluid pressure. Fluid pressure can be classified into two kinds: liquid pressure and gaseous pressure. So what are fluids? Fluids are liquid and gases. They are called as fluid. Why they are called as fluid? Because they can flow. So these fluids, that is liquid or gases, they exert the pressure on the object. These pressure exerted by the fluids are called as fluid pressure. These are a fluid pressure of two types: liquid pressure, gaseous pressure. Now, pressure in liquids. The pressure exerted by the liquids on an object immersed in it and on the walls of container are called as liquid pressure. The pressure exerted by the liquid on an object immersed in it and on the walls of container are called as liquid pressure. Liquid pressure is measured using a device called as manometer. A simple manometer is nothing but a U-shaped tube containing a liquid like water. A U-shaped tube which contains water. One end of the tube is kept open to the air and other end is connected to the rubber tube. And this rubber tube is placed into the liquid whose pressure has to be measured. Now, the water level of the tube varies when we keep the funnel at different position inside the fluid. The difference in the liquid level determines the liquid pressure. So, liquid pressure, that is the pressure exerted by the liquid, is called as liquid pressure. We can measure the liquid pressure by using a simple device called as a manometer. Manometer is nothing but a U-shaped tube which contains water. One end of the U tube is kept open and other end is placed into the another beaker whose pressure has to be determined. Okay, another end is attached with a rubber tube and this rubber tube is placed into a tumbler which contains the liquid whose pressure has to be determined. Now, this tube, U-tube varies, the water level in the U-tube varies as we keep the funnel at different position. Then the difference in the liquid gives the liquid pressure. Properties of liquid pressure. Pressure exerted by the liquid increases with the depth from the liquid surface. Pressure exerted by a liquid at the same depth will remain same. Liquid exert the pressure in all the direction. The pressure exerted by the liquid increases with the depth. At the same depth, the pressure will be same, and all the liquids exert the pressure in all directions. These are the properties of the liquid pressure. Next, atmospheric pressure. The pressure exerted by the weight of an air on an object is called as atmospheric pressure. Air also exerts some pressure on the object. This is called as atmospheric pressure. This atmospheric pressure changes with the altitude. Altitude is height. As we move above, as the altitude increases, the atmospheric pressure decreases. Why? Because at the height, the atmosphere becomes thick, whereas at the sea level, the atmosphere is thick. So, where the atmosphere is thick, the atmospheric pressure will be more. Where the atmosphere is thin, the atmospheric pressure will be less, because the air gases have to exert the pressure on the object. Altitude is the height of the place from the sea level. As we go higher up to the altitude increases. With increase in the altitude, atmospheric pressure decreases. So, as we move up, the altitude is increasing. So, what about the pressure? Pressure will decrease. Why? Because the layer of the air becomes thin. Hence, the pressure exerted by the air decreases. but at the sea level the atmospheric pressure will be more. Why? The layer of the air is thick there. Hence, the pressure exerted by air will be more at the lower altitudes. But this high atmospheric pressure does not affect us, because fluids such as blood in our body also exert the pressure, which cancels the effect of atmospheric pressure. In our body the blood flows, so blood is also a fluid. It will also exert a pressure on the body. So atmospheric pressure and the blood which exerts the pressure on our body both cancels together, and so at high altitude atmospheric pressure does not affect us. Next, applications. Some applications of pressures. It is difficult to cut the vegetables. It is difficult to cut vegetables with the knife with the blunt edge. The knife with the sharp edge has small area and thus exerts more pressure on the vegetables, so that the knife can cut through them easily. So it is difficult to cut the vegetables with the blunt knife, but it is easy to cut with the sharp knife. Why? Because blunt knife has a smaller area, thus exerts more pressure on vegetables. It is very easy to fix a sharp pin on a board, since pressure exerted by it, its sharp tip is high due to the small area as it occupies. Next, dams are constructed in such a way that walls are thicker at the bottom. So when we construct the dams, the walls are thicker at the bottom than at the top, because due to withstand the pressure which is at the which is highest at the bottom, the pressure, the liquid will exert more pressure at the bottom. So to bear that pressure, we construct the dams in a such a way they are thicker at the bottom. Similarly, camels have a flat broad feet when they which help them to walk easily in the sand. Since the area of their feet is more, the pressure exerted by it by its weight on the sand will be less. So broad feet, the area will be more, the pressure will be less. Therefore, the feet do not sink into the sand while walking. Similarly, syringes are used to collect the blood from our body. The blood pushes the blood the blood pressure pushes the blood into the syringe over as we withdraw the plunger. So in this way, the syringes, we take out the blood from the body. So your chapter has been completed till here. Thank you.